Chapter 2, Taxiway Design. You can download full PDF note on airport planning and design from the link below in description in playlist Airport Planning and Design. General. Taxiway are defined part on the airfield surface which are established for the taxiing of aircraft and are intended to provide a linkage between one part of the airfield and another. An apron taxiway is a taxiway located usually on the periphery of an apron intended to provide a true taxi route across the apron. A taxi lane is the portion of the aircraft parking area used for access between the taxiways and aircraft parking positions. The taxiway system should be designed to minimize the restriction of aircraft movement to and from the runways and aprons areas. The clearance distance between the outer main wheel of the aeroplane and the edge of the taxiway should not be less than that given by the following tabulation. Then for the code letter for aerodrome classification letter A, B, C, D, E, F, G, H, the clearance between the outer main gear wheel of an aeroplane and the edge of the taxiway should not be less than 1.5 meters for code letters, 2.25 meters for B, and similarly for DEF 4.5 meter. Width of taxiway. ICAO NX14 recommends different values of taxiway width with respect to different code letter of aerodrome code number or a code letter. For code letter A, the taxiway width is 7.5 meters, and similarly for code letter F, the width of taxiway is 25 meter. Taxiway curve. The recommendation. Changes in direction of taxiways should be as few and small as possible. The radii of curve should be compatible with the maneuvering capability and normal taxiing speed of aeroplane for which the taxiway is intended. The design of curve should be such that when the cockpit of an aircraft, that is the cockpit of the aircraft, that is the nose gear, remains over the taxiway centerline marking, the clearance distance between the outer main wheel of aeroplane and the edge of the clearance between the outer main center of outer main gear wheel span and the edge of the pavement should not be less than those specified before or earlier. Another recommendation on turning radius R is based on the exit speed of aircraft. Exit speed refers to the speed at which the aircraft crosses the edge of the runway as it enters the taxiway, and the radius is given by v square 125f, where p is the exit speed of the aircraft, that is in km per hour. F is the coefficient of friction between aircraft wheel tire and taxiway pavement. The adapted common value of F is 0.13. According to Horonjev, the radius of taxiways should be so provided that the distance of the oldest strut of the nearby main gear is not less than 6 meters from the pavement edge. The relation between the radius of taxiway, wheelbase of aircraft, and specific distance of main gear from the edge of the pavement is given by the following equation suggested by Horonjev, that is R equals to 0.388 into W square divided by T by 2 minus S, where R is the radius of taxiway in meter, W is the wheelbase of the aircraft in meter, T is the width of taxiway pavement in meter, S is the distance between midway point of the main gear and the edge of the taxiway pavement in meter. Example. A taxiway is to be designed for operating Boeing 707 320 with has the following characteristics determine the radius of taxiway. Wheelbase 17.70 meter, tread of main loading gear 6.60 meter, turning speed 80 kilometers per hour, width of taxiway pavement in meter 22.5 meters, and coefficient of friction between tire and pavement surface 0.13. Solution: the radius is given by the p square 125 f and is calculated as 394 meter. From the Orange equations, r equal to 0.338 into w square divided t by 2 minus s, where t by 2 minus s is calculated as 2.19 meter. Therefore, r is calculated as 55.5 meters. For subsonic transport aircraft, minimum radius of turning radius of the taxiways is 120 meter. Adopt the highest of the three estimated values. Therefore, the turning radius for the given data is taken as 400 meter. Junctions and intersection. Recommendation. ICAO recommendations to facilitate the movement of aeroplanes. Fillets should be provided at junction and intersection of taxiway with runways, aprons, and other taxiway. The design of fillet should ensure that the minimum wheel clearance are maintained when aeroplanes are maneuvering through the junction or intersection. And this is the figure showing the taxiway curve. Taxiway minimum separation distance. The ICAO recommendation: the separation distance between the center line of the taxiway and the center line of a runway, the center line of a parallel taxiway or an object should not be less than the appropriate dimension specified in table 3.1. Expect that it may be potential to operate with lower separation distance at an existing aerodrome if an aeronautical studies indicates that such lower separation distance could not adversely affect the safety or significantly affects the regularity of operation of aeroplanes. Then the minimum separation distance between two parallel taxis should be is determined from the figure, that is s is equals to half of the wingspan of the first aircraft plus half of the wingspan of the second aircraft plus the clearance between two aircraft. And this table gives the minimum separation distance for defense code letters and code number given by ICAO NX14. Slope on taxiways. Longitudinal slopes. ICAO recommendation: the longitudinal slope of taxiways should not exceed 1.5%, where the code letters is C, D, E, F, and 3% where the code letters is A or B. Longitudinal slope, and ICAO recommends that 1% per 30 meters for code letters C, D, E, F, and 1% per 25 meters for code letter A or B. And transverse slope, that is ICAO recommendation is that 1.5% for code letter C, D, E, F, and 2% for code letter A and B. Side slope. ICAO recommendations: where a change in slope on a taxiway cannot be avoided, the change should be such that from any point that is 3 meters above the taxiway, it will be possible to see the whole surface of the taxiway for a distance at least 300 meters from that point for the code letters C, D, E, F, and 2 meters above the taxiway, it is possible to see the whole surface of the taxiway for a distance at least 200 meters from that point for code letter B, and 1.5 meters above the taxiway will be possible to see the whole surface of a taxiway for a distance at least 150 meters from that point where the code letters is A. Strength of taxiway recommendation. The strength of a taxiway should be at least equal to that of the runway. Surface of taxiway recommendations. The surface of taxiway should not have irregularities that cause damage to the aircraft structure. The surface of the paved taxiway should be so constructed as to provide good friction characteristics when the taxiway is wet. Taxiway shoulder. ICAO recommends that 60 meters for code letter F and similarly 25 meters for code letter C. Taxiway stripe. General. The taxiway other than aircraft stand taxi lane shall be included in a stripe, and ICAO recommends the width of the taxi lane from the center line is 16.25 meters for code letter A, and for similarly 57.5 meters for code letter F. Rapid exit taxiways. Rapid exit taxiway is to minimize runway occupancy time of landed aircraft. When the angle of turnoff is of the order of 30°, the term high speed exit or rapid exit taxiway is often used to denote its design for higher turn-off speed of aircraft. Location of exit taxiway depends on the following factors such as number of exit taxiways, exit speeds, types of aircraft, weather condition, topographical features, and pyral variability. Then these are recommendation preferred by the ICAO NX14, and the intersection angle of a rapid exit taxiway with the runway should not be greater than 45° nor less than 25° and preferably should be 30°. And this is the typical plan of a rapid exit taxiway. Design of exit taxiways connecting runways and parallel taxiway system. The most significant factors affecting the turning radius is the exit speed of aircraft. Slightly widened in terms of 30 meters is gradually tapering to the normal width of taxiway is preferred. The widened entrance give to the pilot more latitude in using the exit taxiways. The total angle of turn of 30 to 45° can be negotiated satisfactorily. The smaller angle seems to be referable because the length of a car part is reduced. For smooth and comfortable turn, the turning radius should be determined from the equation VR equals to V square over 125F. Recommended minimum radius corresponding to the taxiway speed of small sonic and supersonic transport aircraft are 60 meters, 120 meters, and 80 meters respectively, whatever may be the speed. A high turn-off speed of 65 to 95 kilometers per hour. A compound curve is necessary to minimize the tire wear on nose gear. Therefore, the main curve radius R2 should be preceded by a larger radius curve R1 as shown in figures, but still a compound curve is preferred as it is relatively easier to establish it in the field and its shape is similar to that of spiral. The following radius were found experimentally suitable. That is a given table shows data for rapid exit speedway corresponding to the radius of taxiway. In this case, this is the runway and this is the rapid exit taxiway, and exit taxiway uh, is preceded by a larger radius and followed by the curve of the rapid exit taxiway. The length of larger radius curve can be roughly obtained from the following relation: L1 equals to PQ by 45.5 CR2. The value of C is taken as 0.39. The deflection angle of entrance curve delta 1 equals to 180 into L1 divided by R1. The deflection angle of entrance curve ranges from 45 to 30 degree. Deflection angle of the central curve delta 2 is taken as delta minus delta 1. The length of circle curve is calculated from L2 equals to pi L1 into delta 2 divided by 180. Sufficient side distance must be provided to comfortably decelerate an aircraft after it leaves the runway. The distance may be based on the average deceleration rate of 1 meter per square second. The stopping distance may be obtained from the following relation or equation. That is, stopping side distance st equals to p square by 25.5 d, where d is the deceleration in meter per square second. The stopping distance should be measured from the edge of the runway pavement along the exit taxiway. Available side distance equals to s divided by sine delta minus tw plus tr divided by 2 sine delta. S is the side distance, tw is the width of taxiway, and rw is the width of runway. Fillet radius is taken from fillet radius depends upon the deflection angle. If the deflection angle is more than 135 degree, that is radius is normally taken as 60 meter, and similarly if the deflection angle is more than 135 degrees, the radius is taken as 60, normally 60 meter. This is the typical configuration of rapid exit taxiway. Example 2. Design a high-speed exit connecting a runway and a parallel taxiway at an turn-off angle of 30 degree. The design exit speed is 90 km per hour. The width of runway and taxiway are 45 meter and 23 meter respectively. The separations between the runway and a parallel taxiway is 225 meters. Solution. The radius of central curve R2 is taken from p square by 125f and is calculated as 120 calculated at 498 meters, and for subsonic the minimum radius is 120 meters. Therefore, add up the radius of central curve is taken as 500 meter. By interpolation, the radius of entrance curve R1 is taken as 871 meter. The length of entrance radius is given by L1 equals to p cube divided by 45.5 into CR2 and is calculated as 82 meter. Deflection angle of the entrance curve delta 1 is calculated from the 180 L1 divided by pi R1 and is calculated as 5.4 degree. Then deflection angle of the central curve delta 2 is taken as 30 minus delta 1, that is calculated as 24.6 degree. Length of central curve L2 is calculated from the pi R2 delta 2 divided by 180 and calculated as 215 meter. Required side distance ST is calculated by p square by 25.5 d and is calculated as 318 meters, and the given available side distance equals to 225 divided by sine 30 minus 45 plus 23 divided 2 times sine 30 and is calculated as 382 and is greater than 318 meter. Fillet radius for 30 and 150 degree intersection angle can be 22.5 meters and 60 meters respectively. The plan of design rapid exitway taxiway is shown in figure, and this is the typical figures for the rapid exit taxiway for the calculations after example 2. Apron, holding bay and turnaround. Apron. An apron is a defined area intended to accommodate aircraft for purpose of landing and unloading passengers, mail or cargo. fueling and parking or maintenance. The apron is generally paved but may occasionally be unpaved. For example, in some instances, a turf parking apron may be adequate for small aircraft. And the types of aprons are apron, cargo terminal apron, remote parking remote apron, service hangar apron, general aviation aircraft holding bay. These are located where the aircraft wait for the turn to take off and where they are finally checked before the takeoff. And these are the holding bay shown in figure that are waiting their turn to take off. Holding aprons are usually provided near the runway ends and are made sufficiently large so that if one aircraft is unable to take off because of some defect in the machinery, another aircraft can bypass it for the takeoff. Turnaround. Many airports in the initial stage have low airport traffic and are constructed without a parallel taxiway. As the traffic increases, the need of the parallel taxiway may be felt, although it may not always be feasible to provide it from economic considerations. As a substitute for parallel taxiway, sometimes a turnaround or bypass taxiway is constructed, which also serves the purpose of holding apron. In such cases, the runway is also used as a taxiway. The arrangement is shown in figure, and this is a turnaround. When the aircraft is ready to take off, then the aircraft enter the runway and travel to one edge of the runway, and the edge of the runway is slightly widened with respect to width of the runway, and this widened area where the aircraft can turn to 360-degree turning, and this area is called turnaround. You can download full PDF note on airport planning and design from the description given in playlist Airport Planning and Design.